Okay. Let's get started then. Hello everyone. Welcome to the second webinar organized by Sri Lankan American Knowledge Exchange, or SLAKE. So today we will be talking about the pathway to become a successful graduate student, and we have two speakers on the panel discussion today. So this webinar will be recorded, and the outline for the talk today will be, we'll start off with an introduction to SLAKE, and this will be the outline for the discussion. And if you have any questions, please do type them in the chat box, and we will forward the question to the speakers when time permits. So to give a brief introduction to SLAKE, I would like to invite Darshita Gamage. Darshita is the co-director for SLAKE in Sri Lanka. Hi, Darshita. How are you?
Hi, Rishwi. Hi, everyone. So I'm happy to join our second webinar series and happy to see that we have progress so far. I'll just give a quick introduction about SLAKE, or the Sri Lankan American Knowledge Exchange. So SLAKE was founded to create more opportunities for professionals, professional connection between Sri Lankans in the United States and in Sri Lanka. So it's basically students who are studying in Sri Lanka, maybe graduate students who have come to the United States from Sri Lanka, and also young professionals raised in the United States, but of course with Sri Lankan heritage, and also other researchers and scholars who may be interested in having professional connections with Sri Lanka as well. And our mission is, like our name suggests, is to facilitate exchange of knowledge between students, researchers, and professionals in the United States and Sri Lanka, in order to provide scientific evidence-based solutions and also innovation addressing science, technology, engineering, entrepreneurship, mathematics, and medical related challenges. And we envision an active platform where fellow students, researchers, professionals in Sri Lanka and in the United States can virtually connect, share knowledge opportunities, and contribute professional ideas to spark cross-country connections, stimulate collaborations, and also help to mitigate impacts of brain drain and brain gain. And of course, we would encourage all of you to visit our social media platforms on Facebook and LinkedIn to find out more about us, right? And also we have our website, which is under construction, but we'll be back quite soon. Nimash, would you want to move to the next slide? Yeah, so you can see a brief like a structure of how our team is working right now, and this is SLAKE team that helps and supports in the activities that SLAKE is doing. And of course, we are grateful for everyone who's contributing, and this includes the leadership team of who are Sri Lankans, and also those of Sri Lankan heritage who are based in the United States and also in Sri Lanka. Yes. And just to run you through some of the work that we do, Nimash, if you can also come through this. Yeah, thanks. So we, so in our work, one of the things that we do is we have a publication repository, which is through which we plan to increase our exposure to academic work by Sri Lankan talent who may no longer be affiliated to institutions in Sri Lanka. So it's basically to create a repository with articles submitted by authors who are Sri Lankan or Sri Lankan heritage. And we also plan to create a database which will help better connect professionals in both countries. And we are in the process of reviewing candidates for a database intern and also to support the database development process. And some of our other work include catalyzing connections. It is introducing professionals of similar interests who can work together and collaborate in the areas of work. And also our monthly newsletter, which contains updates of the work that Slake is doing, and also of professional development resources and other opportunities of connections and collaborations that are there. And we also have what we call the Slake Spotlight, where we feature a professional who is a Sri Lankan or of Sri Lankan heritage that embodies our Slake mission and vision. And of course, one of the important activities is the webinar series. So we try to have bi-directional knowledge sharing and connection between both countries. And today, all of you have joined into one of our sessions. And of course, you have the opportunity to read our newsletter. And I think the links have been shared on the chat as well. And also, you can follow us on our Twitter to see what are the publication, how we have launched our publication repository. And also on YouTube, you can watch the last webinar that we had on steps on to successful research publications. So to also let you know how you can connect more with us is if you are looking to collaborate or looking for support for your professional work, you can make a connection request on the form that has been shared on the chat, or you can email to us at slakeorg@gmail.com. You can find the email also on the chat. And again, if you have publications that you would like to feature on the repository, you can also fill the form that also has been shared on the chat. And if you also want to nominate a colleague for the Slake Spotlight, please email and reach out to us. And also you can find the link to subscribe to our newsletter and get continuous updates on the work that we do. And of course, if you are interested in joining us as a member of Slake and joining in with our vision and mission, please do fill the form that has been shared on the chat by Nimasha. So I think that's a quick introduction, but of course, if you all have any further questions, feel free to reach any of us. We also have Rishwi and Nimasha, who are the co-founders of Slake, and also other members of the leadership team who have been working with Slake throughout. So Rishwi, over to you again.
Thank you so much, Darshada, for that introduction. And now I would like to introduce our guest speakers. I'm really excited to introduce Professor Efrain Rodriguez. He is the Associate Professor and Director of the Chemistry Graduate Program at the University of Maryland, the US. And he's the Principal Investigator of the Rodriguez Lab, where he mentors many graduate students and postdocs. And I was very privileged and fortunate to be one of his former graduate students. So currently his research work is focused on functional solid-state materials for really interesting applications like superconductivity, magnetism, and energy-related applications. He obtained his, can I please request everyone to mute their mics? I'm sorry about that. So he obtained his PhD in materials chemistry from University of California, Santa Barbara in the US. Welcome, Professor. I'm really delighted to have you here today. Thank you for making the time.
Thanks for the invitation.
And next, I'm really excited to introduce Professor Neranga Abeyasinghe. He's a senior lecturer at University of Colombo in Sri Lanka, and he's also an alumnus of University of Colombo. He also mentors many students in the chemistry department at University of Colombo, and his research focus is on investigating interactions between light and matter to discover new materials for the potential applications in solar cells, sensors, and imaging. And he obtained his PhD in physical chemistry from the University of Michigan in the US. Hello, Professor. We are really excited to have you here today, and thank you for taking the time to be here.
Thanks for the invitation, Rishwi.
Okay, so moving on. The moderator for the discussion today will be Mevan Zanaika once again. Mevan is the postdoctoral research associate at the University of Rochester in the US. Mevan, over to you now.
Thank you, Rishri. To start off today's discussion, let me shoot the first question at Professor Rodriguez. This is a question that I have asked myself as a graduating senior. Why should one do a chemistry PhD? So I'm sure you would have a personal perspective on it, and at the same time, your views on how a chemistry PhD would advance one's career. We would like to know your thoughts on that.
Yeah, I'll start with the personal because that's probably the easiest one to answer. I chose to pursue a PhD not immediately after my bachelor's. In fact, I took what's in the US they call it a gap year. Maybe in Sri Lanka they also call it a gap year. Essentially, I worked at a national lab for a year between my bachelor's and starting a graduate program. And the national lab was Los Alamos National Lab in the US. And I got to do some amazing research there. I really enjoyed it. I thought, I really want to do this for the rest of my life, where, you know, you get to design experiments, but, you know, you can only do so much with a bachelor's in the sense that you'll always be working under projects of other principal investigators or other staff scientists. And I thought, well, I want the freedom to be able to define my own questions that I think are interesting. And for that, I really need a PhD. And so I shopped around for different graduate programs, and I was really impressed with my PhD advisor, Tony Cheatham, from University of California, Santa Barbara. And so I was really dead set on going to work for Tony, and I ended up working for Tony. And you know, the rest is history. But I would now, with some time from that moment, you know, when I decided to be a graduate student, I look back and as graduate program director now in our chemistry department, I would say for graduate students, think a little more openly than I did when I was a young man, in the sense that when you go to graduate school, it's not about just working for one particular PI, but be open to you know, meeting and selecting the PIs of that graduate program. So you know, have an open mind, and also think about, when it comes to going to graduate school, why go, you know, why get a PhD? It's a very good question, and actually it's one that I ask almost all the students that I interview to be in my research group. And there are varying reasons, but all of them should be about pursuing a career, whether it's in industry, government, lab, or academia, where you get this freedom because of the PhD to actually pursue your own research lines and, as I said, frame your own questions and so forth. Because you don't really need a PhD if you just want to go into a lab and be a lab technician, or, you know, staff scientist like that. That's okay, right? And you know, you could have maybe stepped right into that industry job without the PhD. But if you really want to sort of lead in a research field, or have the opportunity to lead in the research field, you really should consider a PhD in going out for your graduate degree. Let's see. I think we'll get more into this, but I wanted to give my colleague a chance to also answer this. I'm not sure if, Mevan, if you're gonna.
Yes, thank you, Professor Rodriguez. Yeah, but Dr. Neranga, would you add your thoughts on the same question, please?
Yeah, so in my case, let me start with my background. I think some of you guys are somewhat familiar with my background. I actually start with the reason to do like science itself, because if you are going to enter the field of science, then you should be asking some questions right at the beginning. And as you mature, those questions will also mature. So if we can go to my first slide, Nimasha, like if you have it, I think that's basically on the Maslow's hierarchy of needs. Sounds good. So in the meanwhile, I'll start talking. So basically, so when I was doing advanced level in Sri Lanka, so that is somewhat similar to high school in the USA. Advanced level examination is a very competitive exam in Sri Lanka, because most of the students are deciding to go to medical school or engineering school through this exam. So it is not exactly similar to the US or the some other parts of the world system, because in US you get a Bachelor of Science degree first before you get into medical school, before you apply to medical school. But so there's a difference between the systems. So because of those reasons, the advanced level examination is a highly competitive exam, and most of the focus is on entering either medical school or engineering school. So in my case, I was a little bit more curious right from the beginning. So I explored science more, like when I was doing advanced level, and I decided that I was not going to go to medical school. That's like I sat for advanced level through biological science stream. And then I was ranked 41st in the island, but I wanted to do science. I wanted to do chemistry. So at that time, also I wanted to do chemistry. So that's where I started. And then I entered the Faculty of Science, University of Colombo. And then I entered the chemistry special degree program, or we call it the honors degree program. Soon after finishing the chemistry program, or actually before coming to the end of the chemistry program, I was prepared to do a PhD. At that time, we didn't have the same knowledge that we have right now about a PhD. But to be precise, I was like more exploratory right from the beginning. So I had a reasonably good idea that I'm really going to solve problems in the future. So let me start with that thinking. So here I'm showing in this slide, what I'm showing is what everyone knows as like a Maslow's hierarchy. Maslow's hierarchy is coming in educational psychology, where you have various kinds of needs. So it's a need pyramid. And at the bottom, you can see those are all physiological needs, like food, water, warmth, rest. So those are like the basic needs that everyone needs. And if you go further, you can see the belongingness, esteem needs, so prestige and feeling of accomplishment. Those are at the middle. And at the top, you have self-actualization needs. That is basically achieving one's full potential, including creative activities. So when you think about doing a PhD and then going into innovation or research, you have to be thinking about that area. And in reality, uh, everyone has a rough idea, like they don't really know exactly what it is. Everyone has that curiosity and passion to do something to the world, to nature. So that's basically, from my understanding, that is basically pushing everything forward. So what I suggest for students in general is to find an overarching goal or a vision in your life. That vision will change over time. And so in general, it should be focusing on solving problems, advancing the field of science, and contributing to the advancement of the world and sustainability and survival of humanity and nature. So those kinds of lines of thoughts would be there if you are going to go in the direction of science. Nimasha, can you go to slide number 2 also, and then we can move forward. So on slide number 2, what I'm showing is known as Bloom's taxonomy. It's known as the cognitive domain of the Bloom's taxonomy. And as you can see at the bottom, those are very basic skills that people have: the ability to remember and ability to understand things. But if you go upwards, and at the top, you have the ability to create. So you can see that in the uh, in the case of innovation and discovery, you are actually moving more towards that area known as the creation and synthesis area. So in that area, you're actually developing things that were not there before. You are finding things that people never knew before. So those are some of the things that are required in science. So in an education system, ideally, this skill should be the final goal. The creation is the final skill that you have to have. So basically, what I am trying to say here is that if you want to go in that direction, you have to be expecting to solve problems that were not before, and expecting to face challenges that were not there before in a very scientific, logical, and a methodical manner. And you'll be developing the skills that are necessary to do that in your education. That's the ideal scenario. So that's basically my understanding, Mevan. So you can ask further questions if you have any.
Yeah, thank you very much, Dr. Neranga, for that elaboration. So moving on to the next question. So having made the decision to pursue graduate studies in chemistry, like the next most important decision comes about deciding a list of schools to apply. So like from Professor Rodriguez, what I would like to know is from a faculty perspective of being in an admission committee, like what do you usually appreciate about prospective candidates, and where does it get targeted on selecting a pool of graduates, selecting about like 30 or 40 graduate prospective graduate students from a pool of like 100 or 200 applicants?
Right. Yeah. It's admissions is an interesting committee to work in, and I've done that for several years. There, a committee really looks at the whole package. So I want all of the students out there to know that it's not just about getting a really high score on a particular exam and so forth, you know, that's going to get you into graduate school. Neither is it going to hold you back. Sometimes we see some standardized exam score that's not so high, but the rest of the application package looks amazing, you know. So it's the totality of the application process, of the application the students send in. We do admit, you know, twice the number that you mentioned, Mevan, and we about half, you know, go to other places. So you get between 20 and 30 in chemistry, and a little bit more in biochemistry. Uh, for me, when I look at an application, the first document I like to look at is the personal statement, what we call the personal statement, which is the document where you have about 2 pages to tell the admissions committee, why is it that I'm looking at the University of Maryland? And what I want to see there is a compelling case from the candidate or the applicant that they've thought about the University of Maryland, that they've looked at the faculty, that they've looked at the resources, that they've looked at the research that's being done in our department, and made a case to why they would come in and actually want to be part of that research. And so there's that. Then there's the letters of recommendation. And I think those are very, very important, because from the letters you see how did this student, uh, you know, if they were part of a publication, let's say during some undergraduate research, you know, how did they contribute to that paper or to that science, or how did the professor interact with that student? Are they specific, concrete accomplishments of that student that tell me, yes, I see the student coming to graduate school and being successful. The student is curious, is motivated, and has particular skill set in the lab or in theory if you're a student that's interested in theory. And so I need to get a good picture in my mind of who you are as an applicant. And the GRE scores, the grade point average, your transcript, and so on, we definitely look at those, but we need to see those just to know that academically you'll arrive and you'll be able to take our coursework and do fine. So that's what that academic background is for. But really, to know whether you'll be a successful graduate student, we want those other parts of the application, the personal statement and the letters of recommendation. And the CV or the resume will help us make those connections too, where you list out your accomplishments as well. And then we do also interviews. We used to do, I don't think it was Zoom, I forget what what it was that we used to use before all this. But during the interview, we get a sense also of the students' goals and why, why do they want to choose a PhD and why they want to come to University of Maryland in particular. So I remember when Rishvi interviewed, I interviewed her from this desk, actually in my home office, because we had a snowstorm that shut down all of Washington D.C. area, and Rishvi told me about a famous professor from Sri Lanka that was faculty at the University of Maryland, many years before my time, and so that to me, that personal connection was actually pretty important.
Yeah, I think it's about Professor Cyril Ponnam Peruma that she
Yes.
probably told, because I
Yes.
told Richie about him.
Yes.
Oh, really? Okay. Very
All
famous
right.
for his wasn't he doing sort of origins of life type of research? Wasn't
Yeah,
he? Yep.
actually, like in organic chemistry textbooks, I think it was when they talk about the structure of adamantane or something like that. They talk about Professor Ponnam Peruma's work because it's probably that structure he's isolated from soil brought from moon or something like that, as I remember.
Evolutionary biology. Yes.
Yeah. So, Professor Rodriguez, one other question that I wanted to ask was now the GRE requirement for a lot of graduate programs has been waived off. So, in that context, like, should students take GRE, or like what's GRE's role now in the admission process?
That's a very good question. This year we decided to waive the GRE, but if there was some miscommunication between us and the graduate school, and so if you go to apply to our program, it still says GRE requirement. However, we as a department have waived it, and we're not going to look at it this year. I'm not sure if in the future the GRE will return. I think there's a lot of momentum to get rid of the GRE, especially the specialized GRE, like the chemistry or the physics GREs. Those are sort of really moving out. Whether the GRE remains as a requirement, I think that's a big question mark, and I don't have the answer right now. But I know this year and probably next year, it won't. Most programs are not going to look at it. And so it could be that, when we get to what everyone's calling the new normal, right? Post-pandemic, that the GREs just are not as big a factor. I know when I looked at the GREs and admissions, I'd like to look to see if the math and the analytical and verbal, whether they were balanced. because a lot of people think, well, as long as your math is good, you know, you should be a good scientist. And that's not really the case. You know, you have to be able to form logical arguments if you want to write well as a scientist, if you want to communicate your research. And so I always thought, you know, to look at all three scores to give me a sense of the student's aptitude. There's, you know, but I'm not sure if we'll even be talking about GREs in a couple years. So, yeah.
Yeah. So Dr. Neranga, from Sri Lankan students' perspective, like, what did you base your decision on the list of schools that you applied to on? Sort of like, what factors did you consider in deciding the schools that you applied to?
You mean when I was applying to, or
Yeah.
like when? Okay. Yeah. So basically, one thing was from like what I have seen, like from at Michigan and from the other universities also, that as Professor Rodriguez mentioned, GRE is going to disappear gradually. So I'll come to that later. So in my case, I was going through the research of professors, and that's one of the major aspects. But at the same time, when I was doing my application in my third year, I finished doing GRE. Like, so that's like the junior year, at the end of the junior year, and in the in the first semester of the senior year, I did the GRE subject and the GRE general tests. So towards the end of the degree program, I was actually ready to apply, except for the TOEFL score. Actually, TOEFL score was there. So I focused on various aspects. One thing is the schools that can provide me cutting edge research at the forefront of the field. So there's another very important point that I had, like that's probably something that most of the students are going to have. That is how to decide which area you're going to focus on, like which cluster you're going to apply to. Because at Michigan, I remember we had to mention the cluster, whether it is physical chemistry cluster or inorganic or organic, like that. Um, in my case, I really liked all of the types of chemistry. So at that time, I was trying to decide which area to specifically focus on, because I always think about the bird's eye view in addition to the worm's view. So I'll come to that later. So eventually I decided that physical chemistry is going to give me the potential and the opportunity to delve into other areas if I want to in the future. So I kept my options open and applied to the physical chemistry field. So that's one question that students might have. But what I'm saying is at that time I did not know this. So when you're doing research in undergraduate studies, or when you're doing research in your grad school, what you're really doing is you're learning a set of skills, right? You're developing a set of skills that you're going to use in the future. And that might not necessarily be in the field that you are specializing in, and that's also fine, right? But at the same time, there should be a cluster or a specialization area that you really like, right? You should be focusing on doing your PhD in an area that you really like, because you're going to do it for a long time, right? It could be for 4 to 5 to 6 years of hard work, focusing on a specific problem in a specific field. So it must better be it had to be something that you really like. So decide on an area that you really like, and when it comes to rec letters, I suggest you to find recommenders that can write a good recommendation letter about you. So that means your skills as a researcher, as well as your interpersonal and socio-emotional skills, right? Because those skills are going to be paramount when you are going to work in your lab. When you collaborate, you have to have those skills, and when you communicate, you have to have those skills. So basically, social emotional skills are going to be critical. And when the rec letters are written, I specifically focus on those areas: the research skills, the academic potential, and then of course the social emotional skills of students. And it seems that those skills are going to determine how successful you are in the long term. So that's one reason why I mentioned that. When you are really working with your professor doing research for undergraduate students, when you're working with your professor, make sure to be passionate about and show what you really like, and make sure to develop the skills that are necessary. I mean, like the social emotional skills that I have mentioned. And you have that opportunity now at the undergraduate school where you can develop those skills, and those are going to be very helpful. So when it comes to the SOP, there's a very important thing, that is SOP is going to be written before you get the interview most of the time, which means that the committee is going to see you, or like observe you, or like they are going to see you basically through the SOP. So you're going to present yourself through the SOP to the admission committee, right? So keep that in mind whenever you are using that tool. SOP is a tool to present yourself to the admission committee. So usually what I say is the CV is the trailer and the SOP is the movie. And make sure to think about that. So in the CV, you try to put the best uh, part of yourself in a very concise manner. And in the SOP, you expand that, but you are going to show your other skills and your passion to do research, right? So make sure to mention those in the SOP. And another thing that the students may have, another question the students may have, is that do they really have to contact professors before they apply? I think Professor Rodriguez will be able to answer that after in a little bit. So basically the thing is, in my case, I did not apply. I did not email, sorry. I did not email any professor. But there was something that I did, that is, I had really good GRE scores at that time when I was applying, and I had a really good GPA. So since we were, and I am from a developing country, I was really thinking of how much money can I spend on my applications. Based on that, I started emailing the grad coordinators. And I emailed them and I checked whether I stand a chance of being accepted, and at the same time whether they have fee waivers for the applications. So those are some of the things that you can do, and some of the universities do waive the application fees, and that is something that you can do. And the other thing is, in my case, I got really positive replies right away from the grad coordinators uh, after mentioning my scores and my GPA at that time. So I was confident that I was going to get some really good scores.
Thank you very much, Dr. Neranga. They were really important points. So moving on to our next slide about the life in graduate school. So Professor Rodriguez, what is your perspective on like what students should prioritize during after they've started in graduate school, especially in the aspects of like interviewing with faculty and then selecting a mentor and starting and getting started with research during that, in that process, like what are your thoughts on that? Like what helps students to be successful in that process?
Yeah, there there are different stages of your graduate life, right? And so I think this question is going to the first stage, which is joining a research group and becoming part of that group. So I would say that first, investigate the program that you're interested in applying to, because they'll have different requirements for joining a group. In chemistry at the University of Maryland, we give you a semester to join a research group. The biochemistry program, though, gives you a year, but you also have to do these rotations where you actually have to intern in a couple of labs for several weeks, and that's how it goes. And so every program is going to be slightly different in how you join a PI's group. And so do your homework beforehand and see what that timeline looks like and what are the expectations. Now, what you're ultimately trying to do as a graduate student, so these are the expectations you should set for yourself, is you're trying to become the world's expert in your project. Right? You are going to be the sole author of your dissertation, not your PI. You're going to be, your knowledge is going to be greater than your PI's by the end of your graduate career. So keep that in mind. And it sounds a little bit daunting in the beginning, like, wow, I have to be the world's expert in this project. But it's a process, and it takes several years. So you'll be fine. You're no longer going to be a sink for knowledge, rather you're going to be a source for knowledge. So you're going to start creating knowledge, and that takes time to learn how to do as well. And by the end, you should be able to now teach others on what your expertise is, right? And all of this will entail also being able to do two things, which is to talk about your research at conferences and meetings, and then to communicate your research in publications. So you need to be able to to do those two things well. In the beginning, though, you're trying to just understand what are the expectations of the PI, right? For their research group. The PI may require a certain number of publications. They may require you to work within a certain funded project, right? Because each PI will have different funding sources. So even if you like that PI's work, you may not be working exactly on the project that you like, because there's no opening in that with that research funding. And so figure those kinds of things out. Talk to the students and the postdocs of that PI's research group. Dr. Neranga, mentioned about emailing the PI, which I think is incredibly important to do, and don't be afraid to do that. And then when you do arrive on campus, talking to the research group itself will give you a perspective of the expectations of the PI as well. Let's see. I did want to reiterate Dr. Naranga's point about the social aspect of being a scientist. It's very, very important. As you see, this great network, Slake, that's been established, shows you the importance of social networking. You have to be able to join a research group and communicate with your peers, with your fellow lab mates, and with your PI. And if you can't do that, it's going to be difficult to find a support structure when you're a graduate student, and you really do need one. And it could be a support structure that's within the lab, and also outside of the lab, like maybe people in other PI's groups, or maybe even other Sri Lankans that are at the university, right, for example. And so, or the international students associations. Which every university is going to have some aspect to that. So, in early on, getting that support structure in so that you can have someone to vent to, about failures and also successes, right? And be happy and celebrate those. You need that social part, especially if you're moving across the world, right? So.
Yeah, go ahead, Professor
Oh,
Rodriguez.
sorry, I thought I heard somebody. I wasn't sure. And so, yeah, and then once you join the research group in the first year, you have other expectations that are layered on, like, for example, attending your courses, you know, succeeding in getting a good grade. We have certain standards as far as your GPA that you need to maintain. And then going through what we call milestones, like a candidacy exam or a seminar, giving a seminar and so on, integrating yourself into the community that is part of the department. So that means going to seminars, attending seminars, um, supporting your peers in their when they give seminars and so forth. And so, you know, you start becoming more and more part of that community. And then once you pass the candidacy, when you're now a PhD candidate, then it's all about, you know, going in there and doing as much research as possible to publish some papers. And there's one more aspect that you may come across that I didn't even talk about, which is TAing. Many of you will probably TA. Becoming a teaching assistant has its own challenges, I would say, and having to do that, plus, you know, acclimating to life in the U.S. and doing all the graduate stuff, it's a lot. You know, it's a huge time commitment, and that first year you need to kind of find your footing, your balance, and getting all those things done. So, but you know, I'm happy to talk more about those and how I've seen students overcome some of those challenges.
Okay. And Dr. Naranga, so from a Sri Lankan from Sri Lankan students' perspective, like how did you navigate through establishing yourself in US? And also, would you comment on the role of like the support system that's available associated with most universities in US, where we have a Sri Lankan community who would help through ways that they can in establishing themselves? And then also, I would like you to talk further on like what was expected out of you as a graduate student, and what challenges did you face, and how did you overcome them?
Sure. So actually, I'll start with choosing a PI. So once you have got accepted to a program, then at Michigan, we had the rotation system, as Professor Rodriguez mentioned. So we had to do 2 rotations in 2 laboratories before we decide on which lab to join. Actually, at Michigan, we could have done a 3rd rotation if we wanted to. So that's the basic structure of choosing a PI. So once you have decided on the PI, so when you are deciding on a PI, you have to think about several aspects, I think, from a Sri Lankan standpoint. Because what I say is that most of the Sri Lankans are like very, how would I say that? They respect their professors a lot. So that's usually the Sri Lankan student like training. But when it comes to choosing a PI in US, it is more detailed. There are more caveats to that. So one thing that you have to think about is, well, I think the most important thing would be the type of research that you're going to do, and what kind of environment you're going to have in the lab, and the mentor-mentee relationship that you might encounter in the future. So for that, you can talk to the lab members, you can talk to the PI, you can talk to the lab members, and you can talk to other lab mates like in other labs to know about the PI in more detail. And after that, you can make the decision. Usually, one good rule of thumb would be to choose a PI that would have made good mentors. So a mentor that would have made better mentors or good mentors. That's a really good PI usually, like in a very high, in a scale of 0 to 10, that would be like a number 10 PI. So someone who can make good mentors. And the other thing is always think about the work that you're going to do. Are they going to be impactful? When I say impactful, it doesn't mean the impact factor of a journal, because sometimes that's also mistaken by some of the students. Impactful means what kind of an impact that research is going to have, and you're going to work with your mentor. And as Professor Rodriguez mentioned, you're going to be the world expert. You're going to be the master of your project. You're going to be basically the expert who's going to train your PI even if it's required. Okay, so keep that in mind. You're going to be focusing on a very narrow area. So here I can talk a little bit more about the slide number 2 once again, so that we can use that context. What I'm really talking about here is bird's eye view and the worm's view. Now, in the case of a research project in science, when you are doing a very narrow type of research in a very narrow area, you're going to be the expert, the world's expert in that area. There's going to be no doubt. But at the same time, as Professor Rodriguez mentioned, you should be able to communicate that work to a broader public, broader audience, right? The reason is that is how you improve your impact, right? The work impact of your work. So as I said earlier, now at the top of the pyramid, you have the skill to create, and that is the type of skill that you're going to develop while developing rest of the skills. So when you do that, you will be focusing on a very specific area. And I would like to call that the worm sweep. Worm sweep means a worm is on the floor and it can see the nearby grass. And but at the same time, you need to have you need to be able to switch between the worm's view and the bird's eye view. That is basically the bird's eye view means you are flying on the, let's say that you are in a flying above a forest. You are a bird and you can see where the worm is, and you can see where the stream is. You can see where the trees are and the mountains are, like that. So you can see the big picture and how your work is going to impact the broader public, the broader world, nature. So the skill to connect these two areas, the bird's eye view and the worm's view, that's going to be very critical as you develop as a grad student. That is something that I wanted to mention since that's going to be very useful. So in my case, as Professor Rodriguez mentioned, you have to take courses and you have to spend a reasonable amount of time on that. And at the same time, you may have to do TAing or GSIing, like in Michigan, we call it graduate student instructor. So you should be able to balance those skills and you should be able to balance those responsibilities while you do your research. And at Michigan, after your second year, you become a PhD candidate because you have to go through the candidacy exams and you have to defend that. And at that time point, you have to decide on a research committee or the dissertation committee. So Nimasha, if you can go to the next slide. So in my case, I focused, so I had to decide on a dissertation committee. So I chose Professor Raoul Koppelman, Professor Niels Walter, Professor Ethan Geva, and John Scotland as my team. And I was at Professor Ted Goodson's lab. He's on the right corner of the left picture. So he's Professor Ted Goodson. So Ted had a really good team, and he has a senior scientist called Oleg Varnavsky. He's a Russian trained scientist. He had his PhD from Russia. So I decided on joining his group. And after that, the decision was to decide on the committee. And when it comes to choosing the research committee, try to think about a committee that is going to develop you intellectually and challenge you whenever required, so that you can reach your next level as a scientist. So that's going to be a very important decision that you have to make with your supervisor or your advisor. And that is something that I did. And at the same time, when you talk about the support structure, in all cities, usually in US, you have Sri Lankan expats living. You can find Sri Lankan expats, and sometimes you have. So at Michigan, we did not have a grad student at that time at Michigan Chemistry when I was going. It was like a relatively competitive school to attend to. At Michigan, when I was going, we did not have a grad student, but after about 1 year, we had a postdoc coming in, and then, but at the same time, in nearby universities, we had Sri Lankans, and at Michigan State University, for example, I had a really good friend. So like that, you can find a lot of friends there, Sri Lankan and domestic friends. You can find a lot of them, and that's going to be one support structure. And at the same time, your group, you're going to interact with your group for about like 4 to 5 to 6 years, right? And you're going to be one team, and you're going to working on problems, but at the same time, you're going to collaborate with them whenever you have to solve a problem. Sometimes you have to ask for help. Another thing that Sri Lankan students should remember is never hesitate to ask for help if that is not in your skill domain. You can always ask for help. All right. I think that's about it from my side.
Okay, and Professor Rodriguez, so when it comes to graduate students in your group or in general, like based on your experience, what are typical expectations of PIs from their graduate students? And also from your personal perspective, like where have you seen students struggle the most in graduate school, and like what are your suggestions for overcoming those?
Yeah, those are a lot of good questions. Let me see, where I begin. I'll begin on expectations of the graduate students. I really do feel like the two that I mentioned about communicating your science is incredibly important to me as a PI, that the student be able to attend conferences and meetings and not just present their data, right, and say, I took this spectrum or whatever, but to tell a story of what it is that they were investigating, why they were interested in it, putting it in a broader context of results that other PIs and other groups have found in the past, or are, maybe even competing with, right, or whatnot. And so I think that's important because it shows that the student is now mature to the point where they can, they're thinking more like a scientist and not just going in and taking data, right? So that's important for me to see the student be able to communicate that. Second is writing papers. To me, it's really important because we can do research and have fun doing science all day, every day. But if we don't write it up, nobody will ever know about it. And in fact, when you do make a discovery, if you don't write about it, in fact, you will never be known as the one who discovered it, right? And so that, to me, I feel like that is the biggest challenge that I've seen for graduate students, is writing manuscripts. And it has nothing to do with like being a native speaker or non-native speaker at all. It's more about I think a lot of students sometimes are scared of writing, or they're not sure exactly how to start that paper, and so I feel like that is one of my biggest goals, is to help students improve their writing, but not just improve their writing, but even get started on writing and writing up a good manuscript. A lot of that has to do also with reading the literature and being familiar with the literature, but not necessarily, you know, there are all kinds of other factors in there. And as program director, where I've seen this manifest to a point where it becomes difficult for the student to finish is writing up the dissertation. And so that can cause delays, you know, in the student getting a PhD. And so I really want to emphasize writing as a skill set for you to develop, and don't wait to write something, you know, like a really long paper or anything like that. Just practice your writing, you know, a page or two. You know, start with modest goals, and work yourself up. And that's really what I want my graduate students to start learning how to do and do better. Because you're going to need that skill set wherever you go, whether it's industry or academia, wherever, right? We're always writing, whether it's memos or emails or proposals, reports, and so forth. And the better you can communicate your science, the more successful you'll be.
Okay. And Dr. Neranga, so like when it comes to having completed your graduate studies, and when you look back, what do you think were your greatest lessons in grad school? Like what were your key take homes?
I would say that so one of the key take homes was that the story that I told you about the bird's eye view and the worm sweep thing. So that's the key take home, because as Professor Rodriguez mentioned, you could have done exceptionally good work, but if you are unable to communicate it to a broader audience, it means nothing. Right? So that means not only that you should be technically skilled in your field where you are doing your research, but at the same time your ability to write and communicate to a broader audience is extremely important. So that's one thing that I have actually I heard this from Professor Raul Koppelman. Actually, he told me this bird's eye view and worm's weave story when I was having a chat with him. He was one of my dissertation committee members, and I think he mentored Eric Betzig, the 2014 Nobel laureate, a little bit. So he told me stories about that also. So another very important take home is the potential you have as a graduate student, as a scientist. When you do your research, like at that level, like at the cutting edge of science, you realize that this is how science works. Right? This is how science is progressing, and this is how the actual research experiments are done at that level using those resources. So I was fortunate to be the expert in the near field microscopy technique. So I was the expert in the group, and no one actually knew how to do that. And I had to train the best in the group. Before I actually left, I had to train him to do the end sound, like near field microscopy. So that kind of gave me the idea, well, yes, once you have become the expert, you could be one of the few experts in the world who can do those kinds of experiments and who can explore that area. Another interesting thing that I learned was if you are focusing well enough, serendipity plays a major role. I think I went through Professor AP's talk also, and he mentions that, and that's absolutely correct. If you are focusing well enough, serendipity is going to be a major factor, because So I remember when I was trying to repeat an experiment, one of my previous graduate students did. So I was trying to repeat this experiment, and when I was trying to do that, I saw a different observation in transmission for a specific material, which we later, so because of that finding, we changed the experiment and we investigated the material for a different goal. So for example, we were thinking of that as a 3-photon absorption material, and then we changed it to transmission experiment and found that this material is showing singlet fission. So and then what we found another thing that I realized was, once you have found something that is very unusual or groundbreaking, uh, it takes a lot of work to prove that it is groundbreaking. Just remember that, because if you really want to convince yourself, you need to do a lot of work, right? And if you can convince yourself, then of course, and if you are rigorous enough, then you can convince the others. So that's the development that you should eventually have. So those are some of the take-home messages I had.
Okay, so Nimasha, can we move on to the next slide where we, yeah, well, so collaborations is something that Slake would like to capitalize on. So this is the moment to discuss about the importance of collaborations for graduate students. So for Professor Rodriguez, so what collaborations do you have in your lab going on to make your research goals a success? What do you usually consider in deciding which teams to collaborate with, and also like how do you usually strategize on bringing in expertise through collaborations?
Yeah, this is a great question because, nowadays how we do science is so collaborative. In fact, right, if you look at major publications, you see several teams that produce important work. So I did quite a lot of collaboration actually as a graduate student with groups outside the one that I had joined in Santa Barbara. Collaborated with, I still collaborated with Los Alamos National Labs when I was a graduate student. As I mentioned early on, I was a post-baccalaureate intern at the Los Alamos National Labs. And so actually I sort of continued that. And it was really nice as a graduate student because not only did I have my PI as an advisor and mentor, but I had other PhD scientists, some in academia, but some outside, that mentored me as a graduate student. And that was nice because actually many of them are not involved in mentoring graduate students. And so I got, I would say, like almost like a single child type of attention, right? Because I was one of the few graduate students that would go to the national lab and work with these staff scientists. And so it was, for me, it opened my eyes to see how science is really done in the real world, right? That it takes a lot of different skill sets. We become highly specialized when we get our PhDs, right, in a particular topic. But of course, grand challenges in trying to get fundamental knowledge of nature or trying to solve a problem like an application requires multiple disciplines. It's, and so that's why I think collaboration is important. And as a graduate student, you also will start expanding the network that you belong to, right, already. And so, and that network doesn't go away. I think the nice part about being a scientist is like, I still stay in touch with a lot of the people that I worked with in graduate school, and I can always phone them up or send them a quick message, and I see them at conferences and meetings. It's like family reunions, and so that's the nice part about it. And in fact, it's from those connections that the collaborations continue to this day, as now as an independent PI, either with people who are my friends or colleagues or acquaintances even that I've met over the many years at conferences. You sit in these talks and you think, wow, they can probably do a measurement on some of the materials that we make that we can't do on our campus, or they know how to look at the data in ways that we don't know how to look at the data. Or, you know, theory collaborator, especially because I'm an experimentalist. And now getting papers and proposals in sort of requires an experimental theory component or both components to be present. And so it's incredibly important. It's part of being a scientist in 21st century. And so that's why, you know, when Dr. Neranga was talking about, you know, the social aspects and everything, you know, here it's tied in, and you want to be able to, if you want to others to collaborate with you as well, you want to be trustworthy. So you want to, you know, you want to make sure that you're doing good science, and they'll see that. People will know that on your, based on your record, based on the papers you put out there. If they see good, solid work from you, people are more trusting and they're more willing to collaborate with you. So you have to do your part as well.
Also, like among the participants of today's webinar, we would have people, we would have scientists in Sri Lanka who would like to collaborate with scientists in US. So in general, like are there collaboration initiatives in US that Sri Lankan scientists can take part? Or like when it comes to like, you know, funding is a huge issue for Sri Lankan scientists. So are there opportunities where Sri Lankan scientists can collaborate with US scientists and sort of like write for joint grants? Likewise, like on those opportunities, can you speak on Professor Rodriguez? Yeah.
Well, yeah, unfortunately, I don't know of specific ones for Sri Lanka. I know that the National Science Foundation has an international office, and there was a time when they were sponsoring a lot of sort of joint collaborative research grants with many institutions across the world. And I know that there was some fluctuation on funding levels for that office. And unfortunately, I haven't gone back to fully explore that. I've been involved in some international grant proposals coming out of the UK. Unfortunately, most of them did not work out. Some of them did. I did have, we did have one where we sponsored flights back and forth. We had enough money to just go back and forth and give presentations and think about research and collaborate on some studies, and we wrote some papers. We were hoping that we'd grow it to be exchange of students. Unfortunately, that didn't happen. But you know, there are some grants out there. I just don't know of any that are like specific US Sri Lankan ones. But it'd be good to check out the NSF to see if there's such an opportunity out there. Yeah.
Yeah. And Dr. Naranga, so during graduate school, what collaborative opportunities did you have, and how did those support to make your work a success?
Sure. So Nimasha, can you go to slide number, I think, 3 or 4, where we were when we were leaving? And no, the slide before that, the slide above that. Yeah, that one. Yes, thank you. No, the one with my research group. Yeah, right there. Right, thank you. So Yeah, so when I was doing my graduate work, there were like two major projects that I was working on. One was on nanoclusters and another one was on singlet fission materials. And so as Professor Rodriguez mentioned, now this the collaboration in my perspective occurs organically, like naturally. That is simply because, as he said, the problems that we are trying to solve are multidisciplinary, and these disciplines are all interconnected. So those are the real world problems. And in the real world problems, if the disciplines are interconnected, if you are trying to solve a specific problem, you need the collaboration from different areas, and that's basically why we need collaboration. And in my case, so I was focusing on ultrafast spectroscopy, that is like femtosecond spectroscopy and microscopy on materials. That's basically what Ted Goodson's group is about. Therefore, focusing on that area. And so in my case, for synthesis work, we started collaborating with the Carnegie Mellon University. He's the world expert in synthesizing precise, atomically precise nanoclusters. So I was able to work with them. So that's a collaboration. And then when I wanted to use, for example, certain instruments that I'm not trained in, and that might take a long time, we had to use certain instrument facilities. And again, then we have to. Then I collaborated with the engineering school at University of Michigan. Uh, so that's another point at which I had to collaborate. And when it comes to the singlet fission project, we were doing calculations with Juan Casado at University of Malaga, Spain. And then later, when we were delving or investigating that project further, we collaborated with Paul Zimmerman at chemistry. So Paul, I think, just returned from Berkeley. He was hired like around 2011 or 12, as far as I remember. And he was an expert in singlet fission calculations. So it was an ideal match. Because there was a point where we had to move a step further and prove that singlet fission can happen with that particular molecule. And in that case, we had to show that more than one electron is transferred to the acceptor. And that also worked out, and that was also published in JACS. So that those were some of the collaborations that I had. And at the same time, in the imaging project, that is, I did the nanocluster imaging, two-photon imaging using near-field microscopy. And in that one, in order to support my work, I had to use other types of microscopes. So I collaborated with the Smart Center at Michigan. So altogether, when you think about it, and at the same time, you should be able to communicate with the admin staff as well. You know, administrating staff is going to help you a lot if you can communicate and collaborate with them when it comes to those kinds of situations. So basically, those are some of the collaborations. And if I go back to the question regarding the opportunities we have to collaborate from Sri Lanka, I mean, there are plenty. If you, I think, Nimasha, if you go to, so you can start with conferences, right? You are attending conferences and your work. You can go another slide further down, Nimasha. Another one down. Yeah. So I just wanted to show this slide, but I'm just going to show it now because that's going to be relevant here. So this was a situation where I just returned from US after the PhD, and I just joined the Department of Chemistry, University of Colombo. And I was invited to present at the Gordon Research Conference on clusters and nanostructures. That was an honor, basically, to present at a Gordon Research Conference in that kind of a lineup. Soon after I gave that talk, there were many people who came down and said that they would like to collaborate. So, for example, right now I'm working with someone at Stanford on a specific project on nanocluster imaging. And then another one from Japan came and they also said that they would like to collaborate. So there are a lot of opportunities available. So after this conference, I attended Gordon conferences in every year because that was a great opportunity for me to grow my network and find more collaborators. So that actually worked fine. That's really happening well. And what I have to say is that there are plenty of opportunities available for collaboration when you think about US, Sri Lanka, or US, Sri Lanka, or some other country collaborations. There are plenty of opportunities. So that is something that was a really good experience that I had where I found that potential for collaboration. That's basically on collaboration.
Okay, and also I would like to touch on a question that was raised by a lot of participants. Since we are trying to wrap up this whole chapter on graduate school with this webinar, like a lot of students asked if there's any possibility that their SOP can get looked at, or likewise, like sort of like feedback on their application material. Dr. Neranga, would you are you aware of any places that students can reach out in Sri Lanka to receive feedback on the application material? And would you mention them, please?
I think so. The first thing is there are a lot of faculty who had the training in US. For example, at University of Colombo, Department of Chemistry, I think more than 75% of the faculty is trained in US. They had PhDs from US. You can find a mentor or a supervisor who can go through your SOP and give you feedback, and also you can talk to your mentors and strategize how you're going to apply to a PhD program. That is something that you can do. In addition to that, you have a Sri Lanka Fulbright Commission, SL Fulbright Commission, SLUS Fulbright Commission in Sri Lanka, and they usually give some consultative hours where you can get feedback on your visa interviews. But I'm not quite sure whether they go through your SOPs, but I think they should be helping you out in that also.
Yeah, and I think there are some student organizations as well on Facebook and LinkedIn who can connect prospective graduate students with a mentor in US and sort of give that type of support. So moving on to the final stage of grad life. So when it comes to real life job, entering the real life after graduate school. So Professor Rodriguez, what is your advice to students about like the timeline that they should be looking for jobs? At the same time, there are different avenues of opportunities available to students in US. So what is your advice on deciding which avenue to pursue and what timeline that students should be looking at when it comes to applying for jobs?
I like to tell my students that whatever they think is going to be their defense date, that they should look 6 months before that defense date for a job, maybe even sooner than that. And it really depends on what the student wants to do with that PhD, whether they want to go and do a postdoc or whether they want to go into industry. And so, unfortunately, I don't have as much experience with industry. Rishvi went to Intel, and we that certainly chatted a lot about that. before she went. And to me, it's, you know, transitioning to the real world, as you say it's not it takes time, I think. Um, and you know, I when I graduated with my PhD, I had already a job um, that was set because of a fellowship, and so I knew exactly where I was gonna go to right after I defended. And so I did a 3-year postdoc at a national lab, a different national lab. It's called the National Institute of Standards and Technology, NIST, which is what brought me out to the DC area, Washington, DC area. And so I really enjoyed it. I had a blast as a postdoc, I think, because it felt like, you know, you were past all those tests and requirements that you have as a graduate student, right? It was, you have all these milestones that you have to meet. And then as a postdoc, you're sort of like, you know, you're a PhD scientist, you know, go do the research, and you're sort of unencumbered by a lot of responsibilities that you'll have later on as a PI. And so I really enjoyed that. I can say that, you know, it's not going to be obviously a universal experience for everybody, but so I think looking, uh, doing your research and looking hard for what you want to do after your PhD, so that you jump into a place where you feel like you can grow and learn a lot, and not be limited, is incredibly important. And I know a lot of graduate students towards the end, they're a bit reluctant to do this search because they're really worried about the dissertation and the defense and everything. But if you have that job in line, if you have that little bit of certainty that you've added to the future, right, of what's going to happen, then it actually accelerates um, your writing and getting that dissertation done, because you have an end goal, and you know you have certain deadlines, and you have certain places to go. Like Rishvi had to move across the country, right, from East Coast to the West Coast, which is actually a big jump in the U.S. And so um, I think it's almost never too early to think about that next step.
Yeah, I also agree with you on that. Like navigate, I, I never thought the life after graduation really gets as hard as sometimes it has gotten, especially in the middle of pandemic here. Uh, also, would you touch on uh, opportunities of these conferences where you can talk to recruiters, or where you can meet potential, where you can meet PIs for your potential postdoctoral opportunities and all that? Would you brief on that
Yeah,
as well, Professor Rodriguez? Yeah.
I was, yeah, at the conferences, it's good to just go and introduce yourself to the PI. I think the vast majority are not gonna be bothered by that. And I think if it's a natural, organic conversation that you have with them about the research, and you tell them, you know, I'm interested in a postdoc, you know, I work with so and so, I do this type of research, and I'm really interested in your research because of, you know, reasons X, Y, and Z. Um, Sometimes you'll get someone, right, that they may not have money right now, but they'll think about it, and they'll definitely have your CV in case that does, you know, the funding does come around. And then you may get lucky and get a case where the PI is actively looking right now because they have a new research grant and they really want to start moving on getting a postdoc as soon as possible. And so, you know, you would never know if you didn't try, right? And so please don't be shy. I know that many of us as scientists are naturally introverted, and so we're kind of shy about doing these things, but try to overcome that barrier. Also, during the poster session is a nice time to do it. Sometimes poster sessions, as Dr. Neranga said, you know, like the Gordon Conference is an absolutely and fantastic opportunity to do that, because you're having meals with people. You're maybe having a bit of wine or something, the poster session. It's more relaxed. And so it's easier to make that connection. Maybe for industry, one thing that might be interesting to try is, if you go to the big conferences like the American Chemical Society one, you have the vendors that are there. You may talk to the vendors and say, hey, are you hiring PhD scientists like Brooker Instruments or whoever? And you may find that that's kind of an area that you really enjoy talking about, marketing and sales of whether it's chemicals or instrumentation and so forth. And so, that's another possible avenue, I think, of looking for a job if you're interested in industry.
Okay. Yeah, from Dr. Neranga, you transitioned into a faculty position in Sri Lanka just after completion of your PhD here. So there are a couple of things that I would like to ask you. Firstly, generally Sri Lankan system of recruitment takes time. So wow, before, what was your timeline of looking for jobs in Sri Lanka? And then what were the challenges in the transition? So just like as information for people, for Sri Lankans in US who aspire to transition into into a job in Sri Lanka, what do you think would help them make an informed decision about their career?
Sure. Nimasha, can you go to the slide where the Sigiri is? Basically, as Professor Rodriguez mentioned, when you are deciding on what to do after the PhD, I think it's okay to start right at the beginning also. If you feel that you want to, if you have an idea that what you're going to do soon after the PhD, then that's great. But if you don't, think about it. You can talk to your supervisor, you can talk to your advisor, and check for opportunities like right at the beginning. Like you can get his feedback, his or her feedback on what type of jobs that could be available. And as Professor Rodriguez mentioned, so you have plenty of opportunities. If you are in the field of chemistry, there are plenty of opportunities available. Starting, so the faculty positions, we are all aware of that. Faculty positions in USA, like there's a certain percentage of faculty positions available. But in addition to that, in industry, you have companies like Dow, Intel. Some of the universities, they have information sessions where they come to the university and recruit students. So at Michigan, we had those info sessions like from Dow, Intel, PPG, PNG, like that. A whole bunch of companies coming in, and also in consulting industry, because BCG, Boston Consultancy Group, or McKinsey, there are certain consultancy groups that are actually hiring PhDs. For example, I know someone who had a PhD in physical chemistry and who is now working at Wall Street. Because the skills they had in their grad school is going to allow them to be exposed to any other field, right? They can adapt to many fields. So that's very useful. So in my case, actually, I didn't have any pre-planned like notion as to whether to stay in US or come back to Sri Lanka. But towards the end of my final year, like towards the end of the projects, for about 1 year, I was thinking like, what was my decision? What should I do? Because it was not that familiar to me. Like, the environment that you have in US, like you have plenty of opportunities available. So I wanted to think about all these. And so then after about 1 year, I decided that I should come back and do something in Sri Lanka, so that I can pay back to a certain extent. So with that in mind, I thought, well, why not? Because I'm just showing you Sigiriya, which is a rock fortress. I think many Sri Lankans would have seen that. So I was showing this like in my dissertation defense, towards the end of my dissertation defense also. And many of my committee members said that, wow, this is a really good conference destination. So because Sri Lanka is kind of paradise, right? At the center of the island, you have mountainous regions where you have temperatures between about 72 around 72 degrees Fahrenheit or 20 degrees Celsius, and on the coastal area, so you have a large coastal area. So it's actually paradise. So I wanted to come back and work on improving both research and innovation atmosphere in Sri Lanka. So I decided to come back, and so I was very well. Nimasha, can you go to the next slide? So I was welcomed by the Department of Chemistry, and this is where your question comes in. So how's the recruitment process? Uh, Usually once an advertisement is done, uh, within 6 months, nowadays within 6 months you will have the interview, and that's what the Vice Chancellor is planning to do, from what I have heard. And Vice Chancellor, the deans, Dean of the Faculty of Science, and heads, they are all very active now, and they try to do the recruitment, try to basically finish the recruitment process very quickly. Uh, Back at that time, it was taking a little bit longer, but it took about uh, 7 or 8 months after the advertisement. So that's how the recruitment process happens. But nowadays, the department head and the dean, they are very eager to hire highly talented PhD holders who can contribute to the burgeoning or the developing research, because we are trying to develop a strong or much stronger graduate program, and we can talk about that. So in the next slide, can you go to the next slide, Nimasha? So I already talked about that, so we can move on to the so then yeah, I joined the Department of Chemistry. As I said, like, I was very calmed, and then I realized that there are plenty of opportunities for my students also, and they were able to present at ACS conferences. On your left hand side, that's actually a conference that was in Singapore. So that was ACS Publishers, ACS Publications Symposium on innovation in material science and technology. So people like Paul Weiss, Harry Atwater, Zinan Bao, they have attended the meeting. And my undergraduate students, actually, they have presented their undergraduate work at these conferences. On the top left-hand corner, that's Anuradha. Anuradha is now a PhD student in UK. And on the bottom left corner, that's Sanduni. She is actually moving to US to start her PhD, and she was hired by University of Nebraska professor who's a PhD alum at Michigan. So likewise, and on the right hand side, we have Danushki, Sulalit, and Dinindu. They have done a great job in our single fission calculations. And so when you think about it, there are plenty of opportunities for undergrad students as well. And Nimasha, if you can go to the next slide. So this is basically the group that is growing, and I was able to hire one MPhil PhD student also, Mevan. So that was through a competitive funding program. And in that case, we have collaborated, I have collaborated with Dr. Siat Kunwardana and Dr. Hiran Javira from physics, and a few other collaborators from Ruhuna and Javadanapura, and we got about 40 million Sri Lankan rupees. That's about 220,000 USD to construct a surface enhanced Raman microscope, and we actually working on that. So on the bottom middle, that's Dulanjali. Dulanjali is my first MPhil PhD student, and at the same time, as I said earlier, we are moving ahead with collaborations, and since we have a nice bio-nanophotonics group forming, I got the opportunity to transfer a patent by that was actually for a microscope that was invented by a Nobel laureate, and his institution that has the patent is willing to transfer this patent free of charge. That's like royalty-free transfer, so that we can construct the microscope in Sri Lanka. That's a live cell imaging microscope. So likewise, the atmosphere is growing, and the departments are in the process of hiring really good talent to the Department of Chemistry and other departments also.
It's great news of advancing research from University of Colombo. We are very encouraged by these developments, and we even through Slake, we would like to publicize any opportunities to join Sri Lankan faculty, join as faculty in Sri Lankan universities. So thank you very much, Professor Efrain Rodriguez and Dr. Neranga Abeyasinghe for joining this session. And now we are ready to wrap it up. Do we have a slide on
Yes.
as conclusion, Rishri?
So if I may,
yes. I'm sorry, Dr. Naranga, did you?
Yeah, if I may, there's another very important piece on the final slide. I'll quickly show that to you. That's going to be very useful information on industry opportunities, because now in this CMB Chemistry YouTube channel, that's the Department of Chemistry YouTube channel, we are interviewing eminent scientists. So we have interviewed about 20 scientists so far. And if you are interested about industry, we have interviewed some people from companies like Dow, Intel, who are University of Colombo alumni. And also we have Sri Lankan expats who are professors in USA, and we have interviewed some of them. And we are interviewing one who is now a professor at Stanford also, I think in next week. So you can get a lot of information on the opportunities available in industry as well as in academia on after doing your PhD, what are the opportunities that are available. You can actually be exposed to those opportunities by watching those interviews. Thanks a lot for your time.
Yeah, thank you very much. Thank you. Rishi, who's going to take over now?
Yes, so thank you so much both for all your valuable answers, and we had a really meaningful discussion. I do have a couple of questions from the audience if we have some time left. So one question I'd like to ask from Dr. Rodriguez is, when you're looking at applications and at the transcript, are you strictly looking at the GPA, or are you also looking at the coursework that students have taken?
Yeah, definitely the coursework, because if you're getting really good grades in your chemistry coursework, then that weighs more than other coursework. And so it's about having the relevant academic credentials, I would say. And so that's why it's hard to just look at GPA, that one number, and have a total understanding of a student's academic background. That's why we ask you to send those transcripts.
Great, thank you. And there was another question about, so do they need to have a bachelor's degree? I mean, there are certain institutes in Sri Lanka that offer certain like coursework, diploma kind of degrees, but does the US strictly look at a bachelor's degree? Like, how do you evaluate the institution on the transcript? Is there a way to evaluate that?
Yeah, I mean, let me just say something about US versus, you know, say like the UK, for example, right? We just require bachelor's. We don't require a master's, you know, which is different from a lot of other countries. And so that's why you have a 1.5 to 2 years of coursework when you get to the US. Even if you have a master's, sometimes we do waive some coursework if you have relevant courses that you've taken in a master's from the master's degree that you've gotten. But usually that is if you had received a master's at a US institution where there's more compatibility between the coursework of the different universities. And so as far as evaluating international transcripts, that's hard for us, in fact, because we won't be familiar with all the schools in China or Korea, right, or India. And so it is pretty tough. And so many times we defer to colleagues that may be from that country and say, you know, what about this place? We haven't really heard about it before. Obviously, Colombo, we're gonna all be familiar with, right? But yes, of course, there will be some times where, you know, we just won't have that information or that background.
True. Thank you. Also, I'd like to add something to our initial question at the beginning of the discussion. So this is something based on my experience. When I was looking for research groups to join in the US, I mean, we naturally go on the website and look at the research groups and the research areas. So something that I hadn't realized at that time was most of the websites are not up to date. Not all of them, most of them. So I think it would be more useful to refer to the most recent publications of that group rather than strictly looking at the website. So that way you will get the most updated research areas in that group. So if you don't have any questions, I don't see any.
Rishik, can I add something on what you just spoke? Because I know a colleague of mine, so at University of South Carolina, we sort of had a speed dating system for selecting our advisor. We just have a 15 minutes to 30 minutes interview. And then after that, we are sort of like, hey, I'm going to be in this group. Sort of. So I remember one of my colleagues who, when they were going to meet when she was going to meet the advisor, she took a printout of one of that group's most recent publication and had highlighted certain areas that interested her. And that sort of like made that advisor like really select that student. So I think you correctly touched on something that can definitely ensure a student's success in securing a position in a group that they aspire if they read the latest publications and sort of be up to date on what the group is about.
Yes, thank you, Mevan. Yeah, so just a reminder before we leave, we have all these initiatives undertaken by Slake, and please do stay in touch. We intend to extend this webinar series monthly. Stay connected on our social media platforms and also through our newsletter. So finally, I would like to thank you, both the speakers today, Dr. Rodriguez and Dr. Neranga. Thank you so much for being here with us and making the time and sharing all these invaluable ideas and advice with students. We had students joining us today from both the countries. Thank you so much.
Thanks a lot for having us, Rishi and Mevan and everyone at Slake. And I wish you guys all best of luck with all of the great things that you're going to do.
Thank you.
Yes, thanks for having us. This was fun.
Thank you so much. And thank you so much to the Slake team who has always been supporting Slake mission and vision. And thank you to everyone who took the time to take part today. A video recording of this session will be uploaded to YouTube later. Until next time, stay safe and keep in touch. Thank you, everyone.
Stay safe.